Dimension. Physics for everyone welcomes you. Let us learn about dimension in geometry, dimension of a physical quantity, dimensional formulae, four types of physical quantities, and principle of homogeneity. Geometry. A point has no dimensions, only position. A line is one-dimensional. A plane is a two-dimensional. A solid is a three-dimensional. The number of dimensions is how many values are needed to locate a point on a shape. To locate a point in a line, you need either x or y or z. Only one value is enough. To locate a point on a plane, you need either xy, yz or zx. Two values you need to locate a point on a plane. And in a solid, you need three values x, y, z to locate a point in a solid. So, according to the number of values, then the dimension is decided in geometry. Dimensions of physical quantities. All derived quantities can be expressed in terms of fundamental quantities. Let us consider density equals mass per volume. Mass is a fundamental quantity, volume is a derived quantity. Let us write volume in terms of fundamental quantity. Volume as length cube. So, density equals mass multiplies length power minus 3. So, we have here written density is a derived quantity in terms of mass and length to the power of minus 3. That's fundamental quantity. So, derived quantity is written as the product of different powers of fundamental quantity. Derived quantity is written as the product of different powers of fundamental quantities. So, what is exactly dimensions is in physics is the dimensions of densities are 1 in mass and minus 3 in length. This is what is dimension in physics. Let us learn. The dimensions of a physical quantity are the powers to which the fundamental quantities are raised to represent that physical quantity. The dimension of a physical quantity are the powers to which the fundamental quantities are raised to represent that quantity. The notation used to denote the dimension of a physical quantity is physical quantity within square bracket. So, to represent the dimension of a length within the square bracket represents the dimension of a length. The dimension of fundamental quantity, the mass, capital M within square bracket, length, capital L within square bracket, time, capital T within square bracket, electric current, capital A within square bracket, thermodynamic temperature, capital K within square bracket, amount of substance, MOL within square bracket, luminous intensity, CD within square bracket. For angle, pure number and exponent of a base have no dimensions. Dimensional formulae. We write dimensional formulae after knowing the unit or derived with the help of some known formulae. This is very important. To derive a dimensional formula of a physical quantity, we use this technique. We write dimensional formula after knowing the unit or derive with the help of some known formulae. Let us go with force. Force equals mass times acceleration. This is a simple formula we use to find the dimension of a force, or we can use the SI unit of force, that is kilogram meter second power minus 2. So, let us write the dimension of force equals, instead of kg we write m, instead of meter we write L, instead of second we write T. So, the dimension of force equals within square bracket m L T power minus 2. So now let us go with pressure equals force per area. In the place of force, we can write the dimension of force mLT power minus 2. In the place of area, we can write L square. So this formula is enough to write the dimension of pressure. Or we can use SI unit of pressure, that is Newton meter power minus 2. So dimension of pressure equals, in the place of Newton we write mLT power minus 2, and in the place of meter power minus 2 we write L power minus 2. So we get m L power minus 1 T power minus 2 within square bracket is the dimension of pressure. And remember, m L power minus 1 T power minus 2 is not only the dimension of pressure, but also it's for stress, and Young modulus, and for bulk modulus, and for modulus of rigidity, they have the same dimensional formula m L power minus 1 t power minus 2. The speed is a scalar quantity and velocity is a vector quantity, but both of them have the same dimensional formula L t power minus 1. So dimensional formula does not differentiate vector and scalar. The expression which shows how and which of the fundamental quantities represent a physical quantity is called dimensional formula of the given physical quantity. The expression which shows how and which of the fundamental quantities represent a physical quantity is called the dimensional formula of the given physical quantity. Four types of physical quantity: type, physical quantity, dimension, value, and example. There are four types of physical quantity: 1, 2, 3, and 4. Let us learn all these four types with the help of example. Length and velocity. Length and velocity, this type of physical quantity possesses dimension and its value changes. So we can say that length, velocity, they possess dimension and the value changes. So they are called as dimensional variable. They have dimension and the values varies. The next, angle and strain. They are the ratio of the same physical quantity. Angle is equals arc length by radius and strain is change in length by original length. So they don't have dimension and its values are variable. So angle, strain, they do not possess dimension and their values changes, so they are called as dimensionless variable. And the gravitational constant and Planck's constants, these constants values are not changing, they are constant and they do possess the dimension, so they are called as dimensional constant. Pi, e, and natural numbers, all these are not having or do not possess dimension, but their values are constants, right? So they are called as dimensionless constant. So from the word itself, we can say the type of physical quantity. Dimensional variable, they possess dimension and the values changes. Dimensionless variable, they do not possess dimension and their value changes. Dimensional constant, this physical quantity possesses a dimension and the value is constant. Dimensionless constant, this physical quantity do not have dimension and their values are constant. Principle of homogeneity of dimensions. Let us go with the example. V square equals u square plus 2as. We know the velocity as a dimension of L power t power minus 1. So let us substitute that. Same for initial and final velocity. Then acceleration has the dimension of L t power minus 2. The displacement is has a dimension of L, and 2 is a number. It does not possess any dimension. So after squaring, we get L square t power minus 2 equals L square t power minus 2 plus L square t power minus 2. So every term on left and right hand side of this equation has the same dimensional formula. This is what we call it as principle of homogeneity of dimensions. The dimensions of v square, u square and 2as are the same and equal to L square t power minus 2. The principle of homogeneity of dimension states that the dimensions of all the terms in a physical expression should be the same. The principle of homogeneity of dimension states that the dimensions of all the terms in a physical expression should be the same. Thank you, children.